Hello guys, welcome back. In this video we will discuss about unions and enumerations in C. We have already discussed about what structures are. So just like structures, unions are also derived data types and they are very much similar, except the only difference that lies in the fact that like structures use discrete memory or distinct memory storages for all its member variables, unions, what they do is they share the memory. What I mean to say is all elements in a union occupy the same memory. That means if there are four variables, say suppose there are four variables, int, float, char and double in C, then what happens is all these four variables share the same memory location. And if there is some change in any of the member variable, then that will cause change in the other variable as well. That's what it's written here. See, modification of one element in a union causes change in the other variable as well. Now there might be a question that if all the elements in a union occupy the same memory, then what will be the size of the memory that is designated to a union? Well, the size that is given to a union is the size of the largest member variable that is present inside it. See, if union has members with different data types, then the size of the union is decided by the size of the largest member in the union. So for example, if there is say suppose if there are three variables, maybe a short, that is short int, if there is a normal float, and there is long, then the size of the union will be equivalent to the size of a long variable, that is 8 bytes, and all the members will use that same memory. Now let's take a look at this thing. Yeah, see, in case of structure, this is a sample structure given over here, structure EMP, inside which there are two variables, that is char x and float y, and this is the object of the structure. So char x and float y, both of them occupy their own distinct memory. So the size of x is obviously 1 byte because it's a char, and size of y is a 4 byte because it's float. So the total size becomes 5 bytes for this particular structure. Now in case of unions, it's the same, it's the completely same structure over here. That is means the thing is entirely the same. See, union EMP, this one also has two member variables, that is x and y, just like the structure had. But in this case, what will happen is the total memory provided to a union will be same as that of a structure. Will be different from a structure. So in this case, char, the size of char is 1 byte, float is 4 byte. So the larger size is 4. So that's why the entire size of the union will be 4 bytes. So that's what it's written over here. See, allocate storage equal to the largest one. What is that largest one? Largest one is y, and hence the size allocated will be 4 bytes. And this is known as memory sharing. Now let's take a look at the difference between structure and a union. So with respect to keyword, obviously the keyword for structure is struct and keyword for union is union. The size of the structure is greater than or equal to the sum of the sizes of its members. I had already discussed about structure padding, in which we saw that sometimes it happens that the size is greater than the sum of the variables inside the structure, sum of the sizes of variables inside the structure. It might happen that if the member variables are occupying 13 bytes, the size that shows up is 16 bytes. That is due to structure padding. Anyways, but in case of union, the size is equal to the size of a largest member inside the union. Okay. Now memory. In structures, each member within a structure is assigned unique storage area of location. That is what we saw over here. This x, this y, both are allocated different sets of memory, the different spaces in the memory. But in case of union, both are stored in the same bucket or same memory space. Altering the value of a member will not affect the members of the structure. That's quite obvious. In the other example, we had seen how to work with structures. In that case, when we altered one value, the other value remained intact. But in case of union, you'll see in the example that if we alter one value, then the other value will also change. Accessing members. Individual members can be accessed at a time. Yes, in case of a structure, you can always access individual members. But in union, only one member can be accessed at a time. And that is pretty obvious because the memory that is occupied is shared. So in any case you will not be able to access two members at a time. Okay, you have to access only one member at a time. And in case of structure, several members of a structure can be initialized at once, but in union only the first member of a union can be initialized. That means it's pretty obvious, this one also, because just like the previous point, that is only one member can be accessed at a time, this one also only the first member of a union can be initialized, or only one member of a union can be initialized at a time, because again the memory is shared. And if you initialize one, that is as per this one, as per this point, that is value altering point, if you change the value of one, or if you assign a value to one member, then the same value will be assigned to a different member as well. Okay, so before going to the code, we will also discuss enumerations in C. See, enumerations are also user-derived data types. These are used to define integral constants that are to be used in the programs, and these help to make the program easy to maintain. Enumeration, you can find that it will be like analogous to macros, but they're slightly different. I'll tell you why. Next point is, enumerations come handy when you have to set multiple flags in a program. Doing this reduces the overhead to remember the various states. This one also I tell you. See, this point is actually like, say suppose if you have 3 states in your program, that is working, failed, and maybe freezed. So in that case, you can have multiple flags to be set. Instead of declaring 3 macros, you can just have one enumeration, and inside that you can have the value set for all these 3 flags. So you actually don't need to declare macros again and again, and also you don't have to keep the overhead to remember what were your various states in your program. So that overhead gets reduced. Next, enumerations are obviously declared using the keyword enum. Just like structure, we had this keyword struct. In case of enumeration, we have the keyword enum. So that is basically all of theory. Let's go back. Sorry. First, we will see the example of unions. So again, the customary hash include stdio.h. Inside this, we have a void main. And okay. Before going to that, we also, just like in case of structures, we declared a structure. Here also, we have to declare union. So let's write union, my union int var1, comma var2. So again, we obviously have to make this thing. Union, my union object. Let's write obj.var1 is equal to say 2, and over here, as I told you, that you can initialize only one member at a time. So what you'll have to do is over here you must have noticed that I've first written obj.var1 is equal to say 2 or maybe anything 20, and then I'm putting a printf over here. Now why didn't I declare both the variables at once? See, over there I had told you about a point that in case of unions you can only initialize one object at a time. So that is why, or one member at a time. So that's the reason why I cannot write obj1.var equal to 20 and maybe the other variable. So that's the restriction in case of a union. So let's write obj.var1. Now we will write obj.var2 is equal to say 30. Let's put a new line over here. Compiling the code now. Let's see if it gives the proper output. It's taking a little longer. Just hold on. So var1 is 20 and var2 is 30. Now what I'll do is, let us do this and let's just check once whether it works. See, when I did this, what happened is var1 became 30, var2 also became 30. So that is the very reason why we cannot initialize two union members at a time, because there was one point in which it was written that if you alter the value of one variable, then the value of other variable will be altered as well. So that's why we did not see the change, or we did not see that var1 is 20 and var2 is 30. So that was the example of one point. Now say we have multiple unions, then what will be the size of various unions? So let's write this one, union 1. Okay, let's write union 2, and let's make 2 more. So this will be union 3, union 4. So I'm basically showing you all the possible variations that can be done. So for this one, in union 1 I have written 2 variables, that is integer, both are integer variables. Over here let's say one is int and the other one be float. Here let one be a char and other one be a int. Here let us say one is long and the other one is a integer array. So let us write this. Okay, this one will be union 1, this will be union 2, this is object 1, object 2. Let us again copy this thing, union 3, union 4, object 3, object 4, and now we will print the sizes of the different objects. So let's write size of union 1 %d, comma, size of obj1. Let us just copy this line and paste it. So this is size of union 2, this is 3, this is 4, this is 3, this is 4, this is 2. Sorry. Let us compile the code. Probably there is no mistake. Yeah, let's run it. Okay, I did not put a new line, hold on. So the size of union 1 is C. The size of union 1 is 4, 2 is 4, 3 is 4, and the fourth is 80. So in this case, here see we had both integers, so the size will be 4. There is no doubt about it, because both the variables have the same size. Over here, one is int, the other one is float. So let us actually change into long. And in this case, yeah, it's fine. Or maybe, I don't know, short int. Do we have that? Short int, let's see. Now if we see the output, we must see something different. Yes. Okay, in the second case also it's giving me, what's wrong? I don't know, long maybe. What I'm trying to do is that I'm trying to show you that the sizes will be different for the different cases. Yes, see, there we have. So the size of union 1 is 4, which is pretty obvious because both the variables have the same data type. Okay, and the size of int is obviously 4. We already know it. In case of this one, that is, the first one is an int and the second one is long. So the size of long is 8 and size of int is 4. So that's why we are getting a variable which has a size 8. We have the size of the union as 8 because this one is larger. In the third case, we have a char and a short. So size of char is 1 byte and size of short int is 2 bytes. That is why the value of or the size of union is 2. In the last case, we have one long variable and the other one is an int. So this long variable is of 4 bytes and the int is 20. This is an integer array basically. So size of one integer variable is 4. So size of this 20 integer variables declared as an array will be obviously 20 into 4, that is 80. So that's the size of the fourth union. So that's what I was saying, that the union union gets the space as the size of the largest variable declared inside it. And just like we have pointers to structures, we can have pointers to unions as well. So in this case, let us just comment out this one so that you can refer to the code later on. Or maybe I'll write the first one as well. It's got removed. What I'm doing is I'm just writing out that first code also so that you can refer to it later on. Inside the void main, you'll have this. You'll have union 1 obj.var1 is equal to 20, obj.var2 and this one is var2, this one is var2. I hope there is no error. Let's just compile it and check. Yeah, no error. So I'll just now again comment it out. And our third code is pointer to a union. So over here we have this. Now let us write int star pt. Okay, let us write not int star. Instead, what I'll do is I'll take pointer which is obviously of union type. So union 1 star ptr is equal to ampersand obj. So we have a pointer to a union. Now over here, in case of a structure, also how we access the members using a pointer, we access it using the pointer notation, that is this one. And over here also it will be the same thing. So ptr this, and we will print it using the same notation over here, and this one. Let us compile the code and now run it. So we have got the same output. Okay, so that is there is no difference. Basically the output has to be same. There is no difference except of this pointer notation. The rest of the things are all the same. So just like we have pointers to structures, we can have pointers to union as well. And now what can be the application of unions? Well, the application of union can you can see in cases where you don't want several memory spaces to be declared, because it may so happen that at a time you are using only one of the variables, but you have to declare multiple variables. What I mean to say is, it might be so that you have 4 variables, say suppose, but at a time you will use only one of them. So when you have to use only one variable at a time, it's no point to waste several memory spaces with all the 4 variables. So that can be an application of union. So other than that, everything I have explained about union. Now we will go into enumerations in C. So for that, I will obviously make a new file. Okay, let's save this one first and create a new file. I'll save this file as, okay, let's save it as enum.c, or maybe enumeration.c. So the customary hash includes stdio.h. Inside this, let's write this void main. And in case of enum, what I told you was that we declare enum using a enum keyword. So let's say weeks. I am declaring a enum for weeks. So inside this, what I will keep is, okay, let us write it like this only, no problem. I will keep this one as the member of the weeks, that is Monday, Tuesday, Wednesday. These are the days of a week, obviously. Thursday, Friday, and a Saturday. So obviously the first member is a Sunday. So that is our enum. Now we will make an object. So the object is days. So for, we have to obviously say for this is Sunday, I less than Saturday, I plus plus. Let's write I less than equal to Saturday. Printf %d, comma, I. I hope that goes well. I don't know. Let us compile the code. Okay, first of all, one thing, let us put a tab over here. Yeah, so 0, 1, 2, 3, 4, 5, 6. Now in this case, see what is actually happening is that you might have got confused. See, in case of a enumeration, what happens is that we have written several flags. These will act as various flags inside the enumeration, and we have not initialized these flags with anything. So if we do not initialize the flags with anything, the default value that the first flag inside the enumeration will receive is a 0. So this Sunday has a value 0. Sunday is an alias for a value 0. Monday is alias for a 1. Tuesday for 2, Wednesday for 3, Thursday for 4, Friday for 5th, and Saturday for 6. That is why when I had got this printed, that is I is equal to Sunday and I less than equal to Saturday. So basically I am enumerating over this week enumeration. The name of my enumeration is week and I am iterating over it. And the first value that I am printing is Sunday. That is value corresponding to Sunday. So obviously that first value is 0. Now say suppose if I initialize this one with 5. Then what will happen is the first value that will get printed will be a 5. So 5, 6, 7, 8, 9, 10, 11. So if you have initialized this this flag inside the enumeration with something, then that particular value will be printed. And over here, if you have left it uninitialized, then the value of the second one will be the value of the previous, will be one more than the value of previous one. What I mean is value of nth flag is equal to value of n-1th flag plus 1. Okay, so this is what I actually meant. Value of this nth flag will be the value of n-1th flag. But over here, if you say initialize it with 10, then Monday will be 6 because the previous value is 5, but Tuesday will be 10 because I've initialized it with 10. And likewise, Wednesday will be 11 because I've left it uninitialized and the value preceding it is a 10. So that is the concept of enumerations. Let's compile it first and run it. Okay, let's try and print the value of, okay, let's say printf. That was not actually expected. Comma. Okay, obviously, if I write it Tuesday. So the value of Tuesday is coming out to be 10. That's great. Let's comment out this loop and write printf %d, again %d. So we'll basically print that %d 7 times because we have obviously 7 days. So let's copy this thing. So 1, 2, 3, 4. We have this one. Okay. So 1, 2, 3. Okay. Put a slash t here. 4 times, 5 times, 6 times, and one more time. And here I'll write Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. If I do this, you will see that the values that will come out, see 5, 6, 10, 11, 12, 13, 14. So that is what I was saying over here. In this case, I is equal to Sunday. That is, I is getting initialized by 5 and I is less than equal to Saturday. That is I plus plus. So the value of Saturday, what is it? Monday is 6, Tuesday is 10, Wednesday is 11, 12, 13 and 14. So the value of Saturday over here is Saturday is equal to 14. So what I'm telling my loop is that start with 5 and continue till 14. That is what I'm telling to my loop. So that is why it's printing values starting from 5, 6, 7, 8, 9, 10, 11, 12 until 14. So that was the actual reason why that was happening. But over here when I see this, we are getting the proper values, that is 5, 6, 10, 11, 12, 13 and 14. So the values from 7, 8, 9 are not getting printed. So this is how you work with enumerations. Now there are few points that we can assign any values to enumeration that I've already done. You can assign any values, and next point is that the value of nth flag is value of n minus 1th flag plus 1. The next point is that if we do not, that also I've told you, if we do not assign any value to a enumeration variable explicitly, it will automatically begin the first enumeration flag with 0. And what else? That is actually enough. And yes, one more thing is that all the enumeration constants, that means if you have multiple enumerations, say this is one enumeration and maybe you have another enumeration saying weeks 2, say week 1, week 2. So in both of them, you must have different constants. Okay, you cannot have Sunday in both of them. That will obviously show error. What I mean to say is, if you have something like this, say week 2 and week 1. Let's compile it. See over here it's showing an error. That means redeclaration. What it says is redeclaration of enumerator Monday, redeclaration of enumerator Tuesday, Sunday, Wednesday. So you cannot have the same enumeration constants for two enumerations. You have to have it different. So that is all actually about enumerations and unions. And that is obviously all for this video as well. Thank you.